Right now, the most distant humans from Earth are aboard the International Space Station, roughly 400 kilometers above your head. That sounds impressive, until you realize 400 kilometers is less than the distance from New York to Boston. On a scale model of the solar system, where Earth is the size of a marble, the ISS orbits so close it would be invisible to the naked eye. Humanity has sent probes to the edge of the solar system and beyond. We have landed robots on Mars. We have touched the surface of asteroids. But when it comes to keeping a living human being alive far from Earth, the distance we have actually managed is almost embarrassingly small. And the reasons why tell us everything about what it would genuinely take to push that boundary further. The answer involves radiation, psychology, food, time, and one problem that no amount of engineering has fully solved yet. Welcome to Space Review. Subscribe and hit the bell, because we go to the edges of what science knows every single week. The farthest humans have ever traveled from Earth is 400,171 kilometers. That record was set by the crew of Apollo 13 in April 1970, not by design, but by accident, as their crippled spacecraft swung around the far side of the Moon on the way home. It remains the human distance record more than 5 decades later, and nobody has come close to breaking it. The Moon is roughly 384,000 kilometers away. Mars, at its closest, is about 55 million kilometers away. The gap between where we have sent humans and where we need to send them next is not a gap of engineering confidence. It is a gap of survival science, and it has several distinct components that each independently could kill a crew before they arrived. The first is radiation. Inside Earth's magnetic field, astronauts on the ISS are largely protected from the most dangerous cosmic rays. Leave that magnetic shield, and the exposure increases dramatically. A 6 to 9 month transit to Mars, plus surface time, plus the return journey, would expose a crew to radiation doses that current NASA guidelines consider above acceptable lifetime limits for cancer risk. The Martian surface offers some protection, but no magnetic field. The transit offers almost none. This is not a solved problem. It is the single most serious obstacle between current capability and a crewed Mars mission, and no material shielding solution has yet been validated that adequately protects against galactic cosmic rays without adding prohibitive mass to the spacecraft. Even setting radiation aside, the human body was not built for extended time in space. 6 months of microgravity aboard the ISS produces measurable bone density loss, muscle atrophy, cardiovascular changes, and in some astronauts, vision problems caused by fluid shifting toward the head and increasing pressure on the optic nerve. The condition, called spaceflight-associated neuroocular syndrome, has been detected in a significant proportion of long-duration ISS crew members and is not fully understood or reliably preventable with current countermeasures. Exercise protocols aboard the ISS require astronauts to work out roughly 2 hours every day, just to slow, not stop, the physiological deterioration. After 6 months, returning astronauts typically need weeks to readapt to Earth's gravity, relearning how to walk, rebuilding bone and muscle. On a Mars mission, there is no return to Earth mid-journey. A crew member experiencing a medical crisis 200 million kilometers from home cannot be evacuated. The mission surgeon is the only resource available, working with whatever supplies and equipment fit within the mass budget of the spacecraft. The threshold for what can go medically wrong and still be survivable drops sharply with every kilometer of distance from Earth. There is a dimension of deep space survival that engineering cannot fully address: the human mind. No human being has ever been more than 400,000 kilometers from Earth. On a Mars mission, the crew would be up to 400 million kilometers away. Communication delays of up to 22 minutes each way make real-time conversation with Earth impossible. A question asked of mission control takes nearly 45 minutes to receive an answer. In a fast-moving emergency, the crew is entirely on their own. But even in routine operations, the psychological weight of that isolation, of being further from home than any human in history, with no possibility of rescue and no real-time human contact outside the crew itself, is a factor that space agencies take extremely seriously. Long-duration isolation and confinement studies, including the Mars 500 experiment, in which 6 volunteers spent 520 days in a simulated spacecraft, have revealed consistent patterns of psychological stress, sleep disruption, reduced motivation, and interpersonal friction that intensify with time. Managing crew dynamics across a mission that could last 2 to 3 years, in a confined space, under life-or-death pressure, with no external support, is a human problem that psychology and mission design are still working to solve. With current technology and a reasonable level of risk tolerance, the honest answer is Mars. A crewed Mars mission is within reach technologically, though not yet operationally. The radiation problem is the most serious outstanding obstacle, and several approaches are being actively developed. Water walls, using bags of water as shielding material, absorb some radiation effectively and serve double duty as a water supply. Pharmaceutical approaches, drugs that reduce radiation sensitivity or accelerate cellular repair, are in early-stage research. Advanced warning systems for solar particle events, the most acutely dangerous radiation spikes, could allow crews to shelter in more heavily shielded areas during peak exposure. Beyond Mars, the challenges compound rapidly. A crewed mission to Jupiter's moons would require transit times of years, radiation environments near Jupiter that are among the most intense in the solar system outside the Sun itself, and life support systems that must function without failure for durations that push the limits of any mechanical system ever built. With current propulsion technology, a crewed mission to the outer solar system is not a near-term possibility. It is a generational engineering challenge. With fundamentally different propulsion, nuclear thermal or nuclear pulse drives that have been studied but never flown, transit times could be reduced enough to make the outer solar system theoretically accessible to humans within a century. With fusion propulsion, which remains in development, the timescales compress further. The physics allows it. The engineering does not yet deliver it. How far could a human survive from Earth? With current technology, realistically, Mars. That is roughly 55 to 400 million kilometers, depending on orbital position. A journey of months, survivable with significant risk, demanding every capability space medicine and engineering currently possess, and several they are still developing. Beyond Mars, the barriers are not philosophical. They are physical. Radiation, time, physiology, psychology, and the sheer mechanical endurance of life support systems all impose limits that current technology cannot fully overcome. Each one is solvable in principle. None of them is solved in practice. The distance record set by 3 astronauts aboard a crippled spacecraft in 1970, swinging helplessly around the far side of the Moon, still stands. That fact alone says something profound about how hard this is, and how much further there is still to go. The universe is immense. The gap between where we are and where we could be is not measured in kilometers. It is measured in the engineering, biology, and psychology of keeping a fragile living being alive in an environment that was not designed with us in mind and does not particularly care whether we survive it. If this made the ISS feel a little less impressive, and the moon landing feel a little more so, share it with someone who thinks space travel is already routine. Drop a comment telling us where you think the first human beyond Mars will go, and subscribe to Space Review, because next time we are pulling apart another question the universe makes look simple until you get close enough to see it clearly.